Hi everyone, we are Team 179 and we are here to talk to you about the Sky AutoTrack application on behalf of our sponsor, Dr. William Sabados of the University of Alabama at Huntsville. I'd like to start off by giving you guys a little bit of background. We are talking about telescopes, and I'm sure most of you are familiar with the manual telescopes, but we're talking about smart telescopes specifically. They allow for computerized movement, which usually allows the angles at which you're moving to be a lot finer, which matters quite a bit when whatever you're looking at is a million miles away. But before you can tell the telescope where to move, you have to tell it where it's already pointing at. And right now, for the most part, this can only be done manually. This requires knowing your exact coordinates, knowing the time and the date, and identifying 3 different points in the sky to be able to figure out where the telescope is pointed, and this is called manual alignment. Our task with this project is to make sure that we can automate the alignment system for novice users who just want to get out there and start exploring, as well as for professional users who either want to make their work more efficient or they want to remove the human error from their calculations. Currently, there is one existing solution. It's by Celestron. It is called the StarSense Auto Align. If you look at it, it is a piece of hardware, and that makes this particular technology not hardware independent. Because of this, it's also not compatible with every single type of telescope out there that is a kind of a market standard. It aligns pretty quickly in 3 minutes or less, but it is $350, and smart telescopes are already pretty expensive. They range from about $1,000 to $2,000, and even still, that amount of money is not a drop in the bucket. So we are hoping with our project to create an open source software or hardware independent software that allows you to align your telescope. With that, I'd like to turn it over to Ed and Austin for our demonstration.
So thankfully, in order to interact with any kind of telescope, there's what's called the ASCOM standard for telescope drivers that allows us to connect to any telescope. So if we were to start up the program and connect to our telescope, we would hit choose and be able to select which telescope we want to connect to, and in this case, since we don't have a telescope, we'll be connecting to the simulator. And once we connect, you can see that we've connected to our telescope, and we can view our current coordinates here. And we can also send commands to the telescope. So if we want to slew to certain coordinates, we can just send a command to the telescope, and you can see that the numbers start to change as it adjusts to those coordinates that we specified. At this point, if we wanted to automatically align our telescope, we would click this button, and I'll hand it over to Ed for the back end to explain how that works.
Right, so as soon as you click automatically align, basically the job of the app is to take the current image that it's looking at and determine the right ascension and declination of that particular location in the sky. So what we have, or to do that, we're using the astrometry.net API, and that basically allows us to upload an image like what you see here. This is an example of what your telescope might currently be looking at, and resolve the coordinates that we need from that image. So let's just take a look at a few of the commands that we would use to do that. So the first one is just determining, is just uploading the image to the API and getting the results back, or waiting for the job to complete. So let's take a moment to look at that. So while we're waiting for the results, I'll just take a moment to sort of explain a little bit of the difficulty that we've had integrating this API with our app. So the ASCOM simulator is in .NET, which only runs in Windows, and the API is specifically for Unix-based machines. So we've got a bit of an operating system conflict there that we hope to mitigate in the future. But for right now, we'll just show you the backend in Unix. So we've gotten our results back, and to actually view the information that we need, what we can do is take this job status here and paste it into this HTTP request. And then before I run this command, I'll draw your attention to the folder here. So you can see when I run this, we get back this index.html file. And when I open this, you can see that it contains some JSON information. But particularly, we get back an RA write extension and DEC declination. And so those two coordinates right there are the same as write extension and declination over here. And we can use that to identify where that image was in the sky. So that's just a brief demo of what the back end of our app sort of looks like. To summarize, we're using the ASCOM simulator to sort of simulate interaction with a telescope, and any physical telescope that implements that standard we will be able to interface with. And to actually resolve our images, we're using the astrometry.net API.
Alright, moving forward, we hope to create a more polished UI for a better user experience, as well as integrate the front end and the back end. And some additional features we might want to include along the way is the ability for the user to select a known star and have the telescope slew toward that coordinate. We also hope to be able to import and export data from our application. And as far as for testing, we plan on using the ASCOM simulator and as well as a physical telescope. Some issues that may arise along the way of implementing our application are listed here. The emulator right now currently does not provide any visualization of the telescope, and that's something we definitely want to include in our application. As mentioned earlier, Ed said that both the front end and the back end both currently operate on different operating systems, so we hope to resolve that issue in the future. And as far as testing, currently we don't have a budget to purchase any resources we need, and that's going to be an issue when we test our application. So we are going to look into possibly borrowing the Georgia Tech Astronomy Club's telescope for free use. And with that said, I'll hand it off to Nick.
Okay, to wrap things up, we've shown you two small parts of what our finished application might include. Right? And though it doesn't seem like much, it represents some pretty significant progress. Right? These are pretty big steps. Connecting to the ASCOM simulator so that we can comply with the ASCOM standards and work with any telescope that complies, which is most of the market standards, right? That's a pretty big step. And then being able to use the astronomy.net API that can just take an image and see where we are, that's also a pretty big step. So we feel good about being able to take what we have so far and bring it to the final product, which, like we said earlier, is going to completely remove the human component from telescope one and telescope use, making smart telescopes smarter and making astronomy from novices to professionals more accessible for all. Are there any questions?